The world is filled with promises of the next best thing just around the corner, and wireless is no different. Wi-Fi 7 promises to be the fastest thing that you've ever seen. But unfortunately, one of the pieces that is promising that isn't ready just yet. In this episode, we're going to talk about MLO is a lie. Welcome to the Tech Field Day podcast, where each episode we bring together a group of experts from across the enterprise IT space to debate a number of topics and theories in enterprise IT. Tech Field Day is a part of the Futurum Group, and each episode is usually recorded in conjunction with one of our Tech Field Day events. We're here at Mobility Field Day this week, but before we introduce the topic or premise for this episode, I'd like to take a moment for our guests to introduce themselves. Allyn?
I'm Allyn Crowe. I'm a principal engineer at Nexum.
Peter Mackenzie from the UK, and I've been a wireless nerd for 25 years now.
Chris Reed, principal consultant at Verizon, focusing on Wi-Fi.
And I'm Tom Hollingsworth, practice lead for mobility at Tech Field Day. Let's jump into the premise for this episode. No doubt you've seen lots of coverage of something called Wi-Fi 7. You don't know what it is, but you know that you need it because the number is bigger. That means that it must be better. But the primary feature that everyone is looking for in Wi-Fi 7 is something called multi-link operation, or MLO. But unfortunately, I have news for you. MLO is a lie. Okay, let's jump into that because I can hear people typing about how I'm wrong, and Lord knows I love to be wrong on the internet. But gentlemen, what is multi-link operation, and why is it something that so many people are clamoring for in this latest revision of Wi-Fi?
Yeah, so setting the stage first, MLO is the ability for a client to send or receive frames to two different radios, either the same frame or different frames staggered, or to two different APs at the same time. So fundamentally, that's what it is. And the benefit is supposedly both speed increases as well as reliability increases of those same transmissions. It's been the primary seller of the Wi-Fi 7. It's been the hotness for it. But I don't know that, at least to start with, it's going to work at all. We had enough problems with OFDMA. Even now, getting it to work in the real world and having a real benefit from it has been a problem. And that was a technology that was already in use. It was already on radios. They already understood the behavior for it. We just adopted it into Wi-Fi, and it still had that problem. Now you're telling me that we're expecting this to work across multiple APs at the same time. I have real concerns about that happening in the real world, at least in the short to midterm.
We have enough problems roaming between two APs, let alone talking to two APs at the same time.
Yeah, I think that's right. I think the other thing to be said about multi-link operation is it's not just all those benefits, better reliability, increased speed, that you don't actually get all of those. There's different flavors of multi-link operation, and depending on which flavor you implement will depend on what benefit you get. And I don't think that's, people don't really talk about that as much with it as well. And I guess one question I've got is which flavor is actually going to bring a tangible benefit that we'll actually see in enterprise class networks.
Well, I want to back up a little bit here because one of the things that I think we might want to explain also to our audience out there, why do we need multi-link operation? Because I can think of a time back in my formative years when I was studying how to create ether channels and LACP trunks between switches. And at no point was this ever sold to me as, double the bandwidth. In fact, usually the way that it was described was it was redundancy, right? So if one of my cables goes out, that it's still one link and all the traffic's going back and forth between one. In fact, anybody who ever told me, oh, well, if you lag two ether channels together, you're going to get 2 gigabits per second, they obviously didn't know what they were doing because there was a preference for it to pick one channel. Why do we need MLO? Is it going to increase speeds for Wi-Fi? Is it going to increase reliability for Wi-Fi?
Who do we want to listen to, though?
Well,
we want to listen to the marketing people who tell us it automatically makes it faster? Is it the practitioners that talk to us more about, it is going to add reliability, it's going to add survivability, and some of the rest of it? I think that's some of what, at least from my perspective, we run into these days, is especially with Wi-Fi being driven very heavily on the consumer side, everything's all about faster, faster, faster. You said it, you know, in the intro. It's why do I need Wi-Fi 7? Because the number's bigger.
Yeah.
And I think that's really what we, in a lot of cases, especially in the SMB market, we suffer from a technology standpoint. What are we looking to get out of MLO is a great question.
Yeah, and to Peter's point earlier, we have to talk about the separate flavors and the benefit that comes with that flavor. So let's talk about the benefit of reliability. So in that scenario, it'd be sending the same frame to 2 different radios. That way, if one doesn't get there, the other one is going to. You're getting reliability there, but at the expense of you're using double the bandwidth because you're using the other radio's bandwidth as well at the same time.
And
for normal,
and that's just one flavor, isn't it?
Right.
Of reliability.
Yeah.
This
Right.
is the problem with MLO. There's so many different flavors. So sending the same frame to 2 radios requires you to have a multi-radio scenario.
Yeah.
Whereas I think most clients are just single radio, so they're going to be doing what they call single radio, where they're going to be able to establish a connection with, say, a 5 gigahertz and a 6 gigahertz radio of the same AP. But they'll only ever be able to use one of those connections at any one time. So does that increase reliability? Well, potentially, yeah. So one of the problems with Wi-Fi is sometimes congestion. Channels get congested. If you've ever been on a Zoom call on a congested channel, you end up sometimes getting jitter, delay. And especially on 2.4 gigahertz, actually, that's where we see it a lot.
Right.
If you've got the ability to go per packet, actually, I want to choose which link is the least congested. I'm going to send on that link, and if that link becomes congested or interference, which was what one of the presenters talked about, I can then use the other link. I think that does potentially give us a benefit for real-time applications like video and streaming. So I see that as potentially a real benefit. All the other MLO benefits, I'm not sure about.
but it's a lot of complication for a slightly niche use case, because outside of real-time applications, like do kind of standard TCP transmissions, does that need that, or is it only UDP real-time protocols that we care about using that for?
But they're becoming more important, aren't they? Like, and now we're used to asking Wi-Fi design, didn't we? Do you want to do VoIP? We never ask that question anymore because Teams, Zooms, calls are a daily norm in the enterprise office environment. So everyone is doing real-time voice and video now on Wi-Fi. So I think if we can increase reliability of that, I think that can be a benefit. But in terms of all the other benefits of MLO, I'm not convinced.
And I think my concern is, at least in these initial phases that we're seeing, it's still heavily reliant on 2.4, right? In a lot of cases, the clients we're seeing it's 2.4 and 5, maybe some 5 and 6. And I think that as practitioners, we've deprecated the use. We've kind of said 2.4, yeah, we'll do it, but how much do we rely on it to be available and ready to take video calls? Because if we're on 5 and our switch is to 2.4, and we don't have our 2.4 network in a state that's ready for a video call, it's not going to get better. Well, and it's how reliable is that going to be?
And we've been teaching take your 2.4 gigahertz away from your corporate network. I disable it.
Yeah.
So and have different SSIDs on 2.4 and 5 gig. So you can do MLO with different SSIDs.
Right.
So I do think the real benefit will come with 5 and 6.
Yeah.
Not 2.4.
Yeah.
But then we need a wider deployment of 6 gig radios to do that.
Which brings into all the fun that we need to deploy this, right? It's not just MLO that we've got to deploy now, right? As much as we would love to say everybody's doing WPA3, how many people are doing WPA3? And what does that bring into the folks that aren't doing it, and where do we go there?
Well, I think that's a good answer, because MLO requires Wi-Fi 7.
Yeah.
And Wi-Fi 7 requires WPA3. So if you're on 5 gigahertz and 2.4 and you want to enable MLO or Wi-Fi 7 at all, it has to be a Wi-Fi 7 only SSID, which means any legacy clients that are in 2.4 or 5 gig won't be able to connect. And I don't think that's been quite thought through as much. So in the 6 gigahertz band, that's great. That's all fresh. It's new.
Mm-hmm. So if you've got a legacy right now, let's just talk pre-shared key only. So if you've got a legacy 2.4 and 5 gigahertz radio, it's WPA2 PSK.
Yeah.
You swap that out for your fancy new Wi-Fi 7 AP. In order to use this, you have to migrate to WPA3. Your clients have to support beacon protection. Your clients also have to support management frame protection, which is required for WPA3. But in legacy WPA2, when we enabled it, we did have a lot of client problems. So there's a few steps that we have to get to in order to even start to play with this, much less use it and see a real world benefit.
And I'd say, luckily, at least for those people who are running a WPA2 with a PSK, and that's it, it's easier for them, right? It's the enterprises that are on WPA2 with EAP-PEEP or something like that, where they've got to make that jump to EAP-TLS and certificates and the PKI that comes with it and all those things to get to WPA3, to then get to Wi-Fi 7, to then get to MLO. And I know, we also see in some of the hardware where they're 2.4 and 5 only, but they're Wi-Fi 7 APs, right? So now we've got I can't buy these APs because I want to get to 5 and 6, but I can't because that AP is Wi-Fi 7, but doesn't have 6 gigahertz.
Go for it.
No, but I think that's good, though. It's good that Wi-Fi 7 supports all the bands. Like, if we're only focusing on 5 or only had it on the 6 gigahertz radio, it's not as much of a benefit. But I like that it's in 2.4 for specific
I think
cases.
it's got to for MLO to be a thing. I think, though, here's a question. We've talked a bit about reliability and some of the issues. Do we need, if you're using it for throughput, so that's when you're going to split your data over 2 links, do we need it? Do we need more throughput?
Always.
Well,
we always need more throughput.
But obviously, you must have watched the previous episode of this podcast where we talked about the fact that Wi-Fi 7 is fast enough. Because most of the time that we run into these problems where people are complaining that the Wi-Fi is down or that we're not getting enough bandwidth, it has absolutely nothing to do with the underlying infrastructure. And it has more to do with the fact that the application that you're using has bad coding that won't allow it to take advantage of multiple links, or that your AP is only uplinked at 1 or 2 gigs at most, and then your internet connection is 100 megabits or 400 megabits. So it doesn't matter how fast we can get the Wi-Fi to run unless you're transferring a movie from your laptop to your Plex server.
But even then, I'm not totally convinced you need multi-link operation, multi-radio. I'm just not convinced we need it. I think there's a few niche cases, potentially in the home when you talk about, doing VR gaming and you want to have, 20, 30 people all in some sort of immersive VR game that's going to be all connected over the Wi-Fi. There is those type of scenarios.
Right.
But in a standard enterprise, I just don't think users require. I still say today, if you gave me a AC access point, I could probably design it for a wireless network to meet any enterprise's requirements today.
Oh yeah, absolutely. And I mean, we saw the same thing when we started sticking multi-gig interfaces and 10 gig interfaces in our APs, and people are like, we're not even using a gig interface. Why are we doing those higher level uplinks? Well, it's some of the same questions when we're talking the radio side.
6 gigahertz low power indoor is kind of the first time that we've really been able to see it start to push that 1 gig limit.
Right.
So now I think it makes a little more sense to have them in those radios. But remember, that's relatively recent as well.
Yeah.
So we're talking about, do we need extra bandwidth? We just went from 25 channels on 5 gigahertz if you're using all of them. We got that extra 1200 megahertz spectrum, so now we can do wider channels. We're getting more speed from that. Do we now need additional speed on top of it?
Sure.
I don't know how many people at their house are running 320 megahertz channels and have the latest gear that allows them to do some form of MLO because they're, downloading weather data sets.
But I remember, even in my house, my limit is my internet backhaul connection. It's not my Wi-Fi. Yeah. I can max out I get 200 meg at home, but I max out my 200 meg, about 220, over the Wi-Fi. And I was doing that with AC equipment.
Yeah.
I can have my Wi-Fi go faster, but
there's still that push to home, that push in consumer, that consumer gets 7 first. There's bigger, better, massive APs with, porcupine antennas coming every which direction, and I can go faster. They're gaming routers, right? That kind of thing. But yeah, we're still hitting that limit. I mean, we are starting to see higher adoptance of gig to the home. And so, you know, it is coming. But yeah, I think on the enterprise side, no.
So could it be that the reason why consumers get it first, other than the fact that they're more than willing to pay for it, is that they're never going to hit the head limits of what Wi-Fi 7 can provide? So for them, it feels faster because of the placebo effect without all of the features that are actually necessary to make it go faster.
And I think it's that. I think the other piece is a lot of home Wi-Fi is terrible. And so if you're going to take, and we have, let's say it's a gig channel on our, you know, on the Wi-Fi, right? If we say it's a gig theoretical and it's deployed horribly and they're only getting 500 meg, well, if I make that, you know, if I make that gig theoretical 2 gig theoretical and they're only getting gig, it is faster for them. They're still hitting that limit when they hit the internet.
Yeah, but home use, home in the middle of the field is kind of the only place that those super wide channels make any sense.
Yeah.
Because as soon as you get into a neighborhood or you get into an apartment building, there's already enough contention around that you're not getting the advantage of those wide
But they're
channels
still deploying them.
out of the box, like all over the place. These home devices are shipping and coming up with 160 megahertz wide channels by default, 320 megahertz wide. I'm expecting 320 megahertz wide channels by default for the Wi-Fi 7 products as well.
Yeah. But it goes back to one of the things that Sam Clemens wrote years ago about drag racing school buses. Why do we ship them by default? Because that way when they get tested, they run as fast as possible. And I don't have to deal with the fallout of what happens when they're broken. You have to call support and figure out why your neighbor keeps dropping your Wi-Fi connection. But it comes back to bigger number, better. And we've been dealing with that in IT for years.
Yep.
But when you get into the nuance of what actually makes it better and why this isn't ready for prime time yet, how can we approach the stakeholders in an organization who may be hell-bent on deploying this and then hell-bent on seeing massive performance increases and being sorely disappointed with their investment when bigger number, not so much bigger?
I think that's a really key point, and I see this all the time, and I've done deployments. Saw it with AX. We deployed some new AX APs, and I ended up having to turn off most of the AX features. And it was just because of all the, so you think about multi-user MIMO, the channel sounding and the overhead associated with it actually made them have less airtime. So, and when I turned off all the features, it worked better than their own system. But our business unit said we have to turn those features on because that's what we've been sold on. And I was like, you turn them on, they won't work. You know, you're going to see less performance. I've got it optimized, but they just, But from a business point of view, they said, no, we spend money on AX. We want the AX features turned on. And if they don't work, we want the vendor to go and fix it.
Yeah, but before we even get to whether we can use it, if it all works perfectly, the problem is going to be on the manufacturer chipsets and drivers, as well as the client chipsets and drivers. Are they going to implement it properly? Is it all going to work correctly? Are they going to make the calculations to actually have it happen? Or is that calculation going to come up with, I'm never going to try this? Because even if you enable it in the infrastructure, if the client device isn't participating in it, doesn't matter.
And that goes back to the other problem of this is a two-pronged problem. I can go to my favorite big box store or my favorite online retailer and order a brand new Porcupine AP that supports every cool feature set of Wi-Fi 7. And if my iPad from 2019 still goes as fast as it was going, I'm going to rant and rave and scream and leave bad reviews, not realizing that the Wi-Fi client chipset in my device is nowhere near ready to support this. And how do we communicate that to users that, oh yeah, we can definitely support MLO if you're willing to buy everybody in the building new laptops?
And even those new laptops.
The right laptop.
Yeah, you have to buy the right new laptops because a lot of them aren't shipping with Wi-Fi 7 chipsets yet.
Are we getting back to this problem with 802.11n when Belkin shipped a pre-standard version that only worked with one card? because I can tell you what it felt like deploying that to the owner of the company and him wondering why his brand new laptop didn't work with his brand new AP. And I'm like, well, you got to use the card that came with it.
And then it's not just the card, does the operating system support it as well? So with Windows, you've got to be Windows 11 and you've got to have a certain patch installed.
Yep.
Or you're not supporting Wi-Fi, you're not doing any Wi-Fi 7 features.
And maybe that's why Microsoft is forcing all the new updates, right?
Yeah.
But then it comes back to, well, why should it only Windows 11 do it? Because I'm not going to install Windows 11 on my machine because I don't have a TPM 2.0. So why can't you make this work on Windows 10?
Yep.
And then someone's going to come out with a software program that you install on Windows 10 to enable this feature, and it's actually malware, and you know, you've compromised your machine. But people will do just about anything to be faster.
Yep.
So how can we educate the wider populace about the nuances of about why Wi-Fi 7 really is better, but what better actually means?
So I don't think it's anything that we can really do. We as practitioners can really do. This is a tale as old as time problem. This is marketing coming out with statements that are technically true, but not accurate. We ran into this with the wider channel widths and AX and AC and the speeds that they could do, and that you need 5 gig ports on it. You didn't. You absolutely didn't. We come out with data sheets that say this AP can support 1,000 clients. Yes, they can associate. No one's doing anything if it's at 1,000 clients. And it's not just Wi-Fi. It's across other other technologies as well. We look at firewall data sheets and the amount of throughput that they say. Yes, but if you enable any feature whatsoever, it's half of that throughput. This is all just marketing. It's not a technology problem.
Yeah, and I love my friends in marketing, but at the same time, we've got to figure out a way that our data sheets, that our communications, that those kind of things are realistic numbers, not the theoretical max. I mean, we could talk about 4K QAM, right? I mean,
nobody talks about 4K.
I know. Well, why? Because we know it's not realistic. I think that's we as practitioners, the only way that we can do this is continuing to push that talk track of here's the realistic numbers. I've had that conversation with clients. They're like, well, this data sheet says it can support 500 users. Why do you need 5 of them in this area? It's like, well, because it can't, realistically. We have to bring that back.
I think another thing that's worth maybe mentioning, and again, I don't know how we educate people like this, but there's something that one of the chipset manufacturers said to me, is that they will, when they bring out, let's say, a Wi-Fi 7 chipset, the first chipsets out the door are not going to be, there's going to be problems with it, it's not going to work very well, same with the first, but the next chipset they bring out will be Wi-Fi 8. They're not going to bring out a Hayes Hour fixed Wi-Fi 7 one. But if you want to get good Wi-Fi 7 AP, you probably need to buy Wi-Fi 8 AP. If you wanted to have a good AC access point, actually the AX APs were probably the best AC ones, and the Wi-Fi 7 APs are probably really good AX APs. So you've got to not think, so that's why when the vendors are selling us on all these new features, you've got to say, well, actually, no, this is a really good AX AP, because it's actually they've actually improved a lot of the features of AX in the Wi-Fi 7 chipsets. And then all the new features that are probably the stuff that's not going to work very well.
Yeah,
how we communicate that, I don't know.
It's the first pancake problem, right? No matter what you do, the first pancake is never going to look or taste right. And by the time you get to the last pancake, you figured everything out. But except for AC Wave 1 and Wave 2, we're never going to see a Wi-Fi 7 Wave 2.
No, we're not.
We're going to see Wi-Fi 8 Wave 1, where we really worked our butts off to make this reality. So I guess you're just going to have to go with it.
And we've seen that from the vendors saying, yeah, here's all the things that are in even 6E, right? And 7. Here's all the things that are in the spec, but we've only implemented these. And yeah, you may see a Wave 2, and then it's like, no, because the speed we're going.
Because they're optional, not required.
Yeah, and I think that's some of those same communication points that we continuously run into.
But as well, when you're a customer and you're buying this, you're buying a Wi-Fi 7 AP, the future proofing that you get from Wi-Fi 7 isn't Wi-Fi 7. It's 6 gigahertz.
Yeah.
It's not even 6E. It's the spectrum, and you've got that in that radio. That's what gets you the benefits now.
Yep.
Whether it's AI intelligence or autonomous driving or even a foldable phone, we're being sold on the promise of something great that's just around the corner. And it's not quite ready yet, but if you stick with me for a little bit longer, you're going to see something amazing until you have to go buy something completely different because it turns out we didn't know how to make that work in the first place. And I feel like that's kind of where we are with MLO. Everyone keeps hearing about how important it is and how much better it's going to make things, and they're ignoring all of the other things that have been included that improve what's going on. I mean, we've been fighting this battle for years. I remember when people were telling me that 802.11 AC was going to be so much better, except you had to be running on 5 gigahertz all the time to use it because there were no improvements in 2.4 other than removing congestion. So we have to be realistic about what we're actually looking for. And we have to be ready to do the hard work to take advantage of those solutions. And maybe that means upgrading our hardware. Maybe that means leaning on our software vendors to be more supportive of what we're trying to accomplish. But it also means that maybe we have to be realistic about what we're actually needing instead of just hoping that the speedometer goes all the way to the other side and I can claim that it's faster. That'll just about do it for this episode of the Tech Field Day podcast. Before we leave, I'd like to let our guests let you know where you can find more of what they like to talk about. Allyn?
Yep, Allyn Crowe. You can find me on LinkedIn or hit me up at NetSec Plumber because I'm the plumber at a security company.
Yeah, Peter Mackenzie. I'm MackenzieWiFi.com is my website, and at Mackenzie Wi-Fi on LinkedIn, Twitter, Blue Sky, and YouTube.
Chris Reed, you can find me on Blue Sky at the CM Reed, or you can find me on LinkedIn or occasionally in the woods.
And you can find more great episodes of the Tech Field Day podcast by going to techfieldday.com/podcast. You can also subscribe to our newsletter and check out all of the events that we have coming up. Tech Field Day is a part of the Futurum Group, and if you'd like to learn more about our offerings there, please head over to futurumgroup.com. We release a new episode of this podcast every week, so make sure that you're subscribed or that you're following along in your favorite podcast application of choice. Just look for the Tech Field Day podcast. While you're out there, leave us a rating and a review so everybody knows the kind of fun that we like to have around here with technology. We'll be back next week with another great episode. Until then, take care.